So there is a network advertised from this purple router. Let's call it as alpha, beta, gamma, and delta. This network is connected directly here. Using a routing protocol, you distribute the route so that someone from the source can reach the network. So what is the basic building block? It's the routing protocol. You need routing protocol. Now, the help of routing protocol, this router knows about alpha, beta, gamma, delta. This also knows about the same. Right? So routing table is now having the root with OSPF or ISIS or RIP or EIGRP's metric. Understand this. It is the routing table that determines the direction of the packet flow. To that direction, whatever label is received is what going to be used. Now, what it means is, I already answered, but I'm going in detail. For this guy, for this network, this guy has said my local label is 30. This guy has said my local label is 26. This guy has said my local label is 18. Through LDP, this 18 also comes. Blue has given 18. Black has given 30. Your confusion is how it knows that this label will be used, should be used to go to the destination. Why not this one? It will not use this one. Why? Because to the Ceph table, the outgoing label will be added. Ceph table is showing as per the routing table, as per the routing protocol. The routing table says you need to go here to reach alpha, beta, gamma, delta, which is going to be seen in Ceph table also. So Ceph table is not going to have 18 as the label. It's going to have only 30 as the label.
But it doesn't. But isn't that the whole purpose?
Blue will use label 26, which is given by green, and black has got label given by green and label given by the downstream purple. Let's say the label here is 18. So the purple given label is 18. Again, let me repeat your question. Your question was how this black router knows that I should use 18, not 26. If it takes 26, it will go in reverse path. It won't go to the destination. How, when you have both the labels, how without any confusion, when you have all three labels, how without confusion it uses 18 is what your question is. Answer is Ceph. That's why I said for MPLS Ceph is very important. Ceph is pointing towards the purple router. So the purple router given label is what going to be the outgoing label for the network. Understood?
Isn't the whole purpose of MPLS is, having this label protocol is the fact that it does not look at the layer 2 or layer 3 protocol.
It will not look into layer 3 header in your packet. See, now the packet is coming from this router.
Mm-hmm.
It will come with the label what? 30. You agree?
Yeah.
30.
Yeah.
As soon as it looks 30, it knows that I need to use 18 because Ceph table point towards purple router. And it goes here. Of course, it did not use a layer 3 header. It is just swapping the label 30 with 18 and forwards the packet downstream.
So in your scenario, basically, a color of the the purple color will probably represent a subnet,
Router ID
right?
of no. Router ID of the router. This is the network. P means it's the router ID of this router. G means it's the router ID of this router. Then the gateway address, you can say the gateway. I need to go to this gateway.
Okay. How to reach to the network, basically. Right. Okay.
Yep.
Okay. And then would that become a label 3, or the ones that are connected next to each other?
Repeat again.
So for example, you've got these different routers: blue, green, black, purple, yeah. So if we concentrate on blue here, right? Now any interfaces or any sub networks directly connected will not have a label. Agree?
Very clearly said. Very correct.
Yeah. So they will not have any a label attached
because they are directly connected. No, they are not.
Because they are direct.
They are not learnt route. It is directly connected route. So if you will give a label for that, a neighbor will use the label, then you will start processing the label, and then you will understand it is directly connected. So again you will process layer 3 header, then you will push it through directly connected. To avoid this two lookups, label lookup and route lookup, for the directly connected, we just put on label called 3 and send to green, so that green will just pop whatever the label that came from black and push the packet without any label, without any MPLS layer. Now blue has to now scan the layer 3 header and read IP address, not the label, and understand that this IP address is directly connected to me on so and so interface, and push the packet over that interface.
So as we said, so blue, all the directly connected will not have a label. But if you have a look at this, the green router, which is directly connected to blue, right? The subnet
for this network and this network, green will not give, means blue will not have any label for this network as well as this network. But blue will have labels for this one. It will have
this one.
But for this one, it won't have. For this
one, what if there's a loopback interface on the router itself, green router?
Yeah, for loopback also it won't have. It won't have label. In blue, you won't find a label. It will simply send without label.
Okay. Now my question is, on the green one, I can see this WAN link between blue and green is directly connected, but the loopback on the green is not directly connected. The link between green and black is not directly connected to blue. Why will that not have?
Understand. Please understand this. Let me reframe. Green is giving label. Green will not give any label for directly connected. It means green will give a label number 3 for all the connected loopback,
Oh,
and the network between black and green, and also for the network between blue and green. Green is going to, the green router is not, it is going to say to blue, don't put any label because it is directly connected. How it says? By putting label number 3, it says to blue. So blue, when it sends the packet for the loopback of green and also for the network between green and black, it will not have any label because green told not to put any label.
not okay. In the same way, when the green router gives label to will pass information on to black router, it will tell the black router not to put any label on the link between black and green, a blue and green, and the loopback interface on the green router because they're
Very
directly
correct.
connected to green router,
Very
right?
correct. But for the network behind the blue, there's going to be a label given, a unique label given, which will be used by black to communicate to green.
Right. Okay.
Any more question before we move?
So if I was to summarize all of this, so basically the simplest way to say is all subnets connected to the local router or the directly connected routers do not have labels.
Correct.
Yeah. So which means all the subnets on the black router, local subnets, and all the subnets directly connected to the routers, which is router green and router purple, right? They will not have labels on under a set table.
Yeah, correct. They will not have a label because they were told not to use any label.
Not to use any label, yeah.
That's why they don't have a label.
Okay. Now that bit I understand. Now, sorry, my next question is, so let's just say if router black, just how you put that down here, router black is learning the same from router B and the purple router right at the end, right? It will look at the label and then forward the traffic on because it will know which is the fastest route to that network or to that router ID. And for that, it needs to look up on the routing table. Is that right?
And no. See, repeat the question. Repeat the question. You will understand. When you repeat one more time, you will understand the answer.
Okay. So I suppose what I'm trying to say is, so let's just say a router green is learning a network from route B as well as purple, right? How will it work out which way to send the traffic, whether it should go down the B route interface or the other one, by looking at the label? Right?
No, not by looking at the label. Understand, this is what I started in the beginning. This was the question also in the beginning. I thought I answered, but I'm going to answer again. You see, routes are advertised using routing protocol. Routing protocol will show the direction as according to the metric. The path with the lower metric is going to be the elected path. Yes?
Yeah.
Okay. That path is already there where? In the Ceph table.
Ceph table, yeah.
Now to go to that path means to go to that next router, what label to use will be copied from the binding table. According to green, to go to purple, the label given by black is what need to be there in the Ceph table, not the label given by blue. That's how the direction is determined. It is
right.
Routing protocol decision, routing tables decision. The routing tables decision is what you will have in the Ceph table. Ceph table is what showing the direction.
Okay, just to confirm, Ceph table is the one where you only have a single route, a single one,
single
not
gateway.
the remote. Yeah, no, when you have the local label and the remote label. What is that table called? Just to confirm.
That's binding table.
That's binding table, right? Okay.
See, forwarding table will have incoming label and outgoing label, which is local label and the label towards the black.
Yeah.
Whereas binding table will have local label, blue label, and the black label for the network. Binding table will have on the green router. Binding table will have local label 26, label given by blue, which is 18 for the same network, label given by black for the same network, which is 30. Whereas forwarding table or fib table will only have
one,
the local and the outgoing. And the Ceph table will have only outgoing. Ceph will have only outgoing. Fib table, label forwarding information base, fib, that will have a local label which is called incoming label, and this is what outgoing label. So if someone sends the packet with 26, which is an incoming label, he has to swap with 30. So the forwarding table will have this both. The command to see the table is show MPLS forwarding table.
Yep.
When you type this, you will have incoming label, which is 26, and you will have outgoing label, which is 30. For which network? Alpha, beta, delta. And this command show IP Ceph for network alpha delta will have the next router gateway, which is black, and the interface via which it has to go, and then the label given by black, which is 30. Only outgoing label on this direction to this router, on this direction. Ceph table will have only this. Forwarding table will have both in and out. Binding table will have this 3. The command to see the binding table is show MPLS LDP binding for the network.
Right. So it's important to understand which table which have what information.
Local label, adjacent left, adjacent right. All 3 labels will be seen.
So I'm just googling this command just to see what the output looks like. So it will have the interface details. It will have the hold time on it. It will have so it will have all of that information. So the table that I was talking about is the other one, which is the Ceph table. I show IP Ceph.
Not if you simply type show IP Ceph, you will not see label. You need to Google will not show you label if you simply type show IP Ceph, because it is MPLS related. No, so
is it show?
No, there is no command special command. If you enable MPLS, it will have label. So you just type like show IP Ceph with label. Just Google with label.
So is that an LDP command that you need to run to see the label?
No. Simply show IP Ceph. If MPLS is enabled, you will have a label. If you don't have MPLS, same command, you will not have a label. Same command. There is no special command. Same command. If you have MPLS, you will have label. If you don't have MPLS,
Right.
Ceph table will be without label.
Okay. That's fine. Okay, that's fine. Yes, because it's important to understand how this label works if you want to understand MPLS. So that's fine.
Yeah,
That is fine.
you're right. MPLS is label. We have to do the proper study. All right. Now MPLS layer 3 VPN. MPLS layer 3 VPN. What is VPN? A tunnel, a virtual circuit. You can also call it as virtual private network. But this is not a secure tunnel. This is not an IPsec VPN. IPsec VPN we'll be learning as a next topic. This is MPLS VPN. This is MPLS VPN. So let's assume you got a provider edge 1 and provider edge 2 in a service provider environment. This is a service provider topic. And now we got many routers. I'm just drawing 3 routers. Assume we have many routers. Now the customers are connected to the provider edge. That's why it is called as provider edge, because the customer edge is connected to the provider edge. So the provider network starts from here. Customers are coming. This is red customer. This is green customer. And then the orange customer. 3 different customers.
Yep.
Now I want to take the routes of the red customer, give it to the remote red. Likewise green. Likewise orange. So that this remote office can ping the head office. So I want this orange to ping each other, green to ping each other, red to ping each other. For that, who has to support? The service provider has to support. The service provider need to learn the routes of this customer and advertise it to the other side, so that they can reach this local. These red, green, orange routes, are they important for provider? No. They're not going to reach the customer. They don't have any business. So it's unnecessary to learn the customer route in these routing tables. So what we do is we form a tunnel between this router to this router, so that whatever the red is given, it will be taken in a separate red table called VRF table, green table, green VRF, orange table, orange VRF, And now the routes from the red, green and orange will go through this tunnel and get downloaded in this red and go to this red. Green will take the same tunnel, go through the tunnel, get downloaded in the green table and go to the green router as an advertisement. And orange will
they not have separate tunnel, or would it be just one tunnel?
Hold on, please. Orange will have its own routing table on the remote and get delivered to the orange. Now, if you call this a separate tunnel or same tunnel, it's your wish. I'm going to give you picture which will give you answer both yes and no. It's up to you. See, the tunnel that you are going to form between PE1 and PE2 is with one IP address. How many IP address? Only one IP address with which you negotiate and build tunnel. Then how many tunnels? One tunnel. One VPN. Inside that VPN, to differentiate that this is a red route, this is a green route and orange route, instead of color, I use another ID called route target. Now, if you say each route target is a separate tunnel, you can say that also. It's up to you. Some people will say this has got 3 tunnels. 3 customer, 3 VRF, 3 tunnel. But if you see from BGP point of view, it is only one tunnel and route targets are extended community values. But if you just ignore BGP and see, then you will see each target is a unique ID, then it is unique tunnel. It's your wish. If you say 3 tunnel, then I'll say yes. If you say 1 tunnel, then also I'll say yes. Because as per BGP perspective, it is 1 tunnel. According to MPLS perspective, since you have different community value, tag value, which we call as route targets, I'll still agree with you, yes, because it has got different route targets to negotiate, and these 3 are 3 different tunnels. Yeah?
Yeah. So basically, yeah, that's fine. So if I was just to do a recap, basically what you would do is on PE1, you will create 3 different VRFs, right?
Very correct.
On PE2, you will create 3 different VRFs for each customer. What you have is you have a BGP, a neighborship between PE1 and PE2, and then what you do is you have a tunnel going across, but each customer will have its own route target. So let's say PE1 will talk to only the route target on PE2. It will not talk to anything else.
See, for green you have a separate route target.
Route target, yes.
For red you have separate one. For orange you have separate one. So that orange route will not get imported on green on the other side. Okay. Likewise, red route will not be imported on orange on the other side. What keeps them separate and unique? It is the route target values. We learned route distinguisher, but route distinguisher is just to differentiate the routing table of each customer. We already did that even in the previous class called VRF Lite. There we did not use a VPN, so we did not use route target.
Yes.
So route distinguisher was more than sufficient. Now we, along with route distinguisher, we add route target to this, so that
because it's going across the VPN.
so that inside the tunnel each customer routes will be differentiated. A route distinguisher can only differentiate inside the provider edge only. It cannot differentiate the routes of the customer as it is going through the tunnel. So through the tunnel, if you want the differentiation between red, green and orange, you need another ID, which is what called as route target. Hope you understand the word route target. It helps to identify the target where this route to be delivered. Whatever red advertises from left, it goes to the red on the right. It is not going to green on the right, because route target has targeted only the remote red and not the green.
Sure.
So this is again another 64-bit value, like a route distinguisher. Route distinguisher size is 64-bit. Route target value is also 64-bit. And this is carried as a BGP extended community value. And you don't need to worry about this extended community values, because it when you configure route target, automatically extended community gets enabled in BGP, and BGP will automatically get configured with the communities. You are not going to configure any community. You are not going to put any command related to BGP community. They get configured dynamically. So if you are not that good in community, you no need to worry.
So we don't need to worry about community, because it will be done automatically.
Right? Is this clear?
Yes.
Okay. So let's do this in action. Between P's, it's not just simply IBGP. Along with IBGP, we need another session called VPN session. So that command will be additional now.
Right. So all these MPLS routers, do they have like BGP VPN running on them?
Come again?
All these MPLS routers.
All right. So we got now one. This is a customer.
Yes. So sorry, I was just asking you a question. So these across the MPLS network. So I'm guessing all these routers, they're configured with BGP VPN.
No.
Is that how they run it?
Only the P routers.
Only the
P routers will run BGP. No other router. So no router reflector, no configuration, nothing needed.
Right.
That's why we have VPN, so that you can avoid running BGP on every router. There is no need for
in between all these routers, because I'm sure one place to another you probably have a lot of routers in between. My question is, what would those routers will be running
MPLS
other than MPLS? No, but
MPLS
do you
and
not need
IGP, no BGP. MPLS
no BGP.
and normal IGP routing protocol to provide IBGP reachability. You need to have a IGP, like OSPF. Something should be running between R3 to R6.
Right. Okay.
So we will.
So even across the internet routers or MPLS routers, you need to have the IGP running.
Of course.
IGP.
Between R3 to R6, we will have a common routing protocol. That can be a private network because it is within the service provider network. So the VRF connected, the customer connected interface will be a member of VRF on R6 and R3. On R6 and R3, the customer facing interfaces will be what? Member of VRF. That will be a public IP address. This will be public IP address here, this will be public. But between R3 and R6, there is no need for what?
Public IP, it will be internal IP.
It's internal service provider network. You need just reachability between R3 to R6 loopbacks. Alright, so I'm going to have a loopback interface on all the routers.
Because I was looking at the, the exam course. I'm just trying to move it. It's not.
Hold on. Let me start this. Okay, done. I have started this. You can start configuring now between R3 and R6.
Yes, so just bear with me. I'm just trying to move the screen from one screen to another, to the bigger screen. It's not letting me. For some reason, it's coming up on my small screen, not on the big screen, and I can't change it. Right. I just do the normal IPs that we normally use.
Yeah, between
normal...
R3 to R6, normal IP address with some routing protocol. Do not focus on customer-facing interfaces.
Yeah.
Do not focus on customer-facing interface.
Okay. So I am not configuring R1, R2, R7, and R8.
Yeah, and they also don't configure G00 of R3, G1/0 of R3. Customer-facing
interface. So, just basically
only service provider network.
Just the circle that you've done. Just
very correct.
Yeah,
including loopback.
And I'm configuring MPLS between.
Yes, MPLS and an IGP protocol.
Okay.
You need to have a loopback interface on every router, and that should be advertised in your IGP protocol.
For router 4 and router 5 as well, yeah?
Yes.
Okay. No worries. Give me 5 minutes. I'll get that done.
No problem. Take it. Check, by tracing the route from router 6 to router 3 loopback. Trace 3333 with the source of .6.6.6.6. Wonderful. Now go to router 5. Show MPLS forwarding table. Enter. You see, to reach 3333, you have a local label and the outgoing label. Are you seeing that?
Yeah.
Okay, now type show IPsef. Show IPsef 3.3.3.3/32. You see, got the label there. And this is the outgoing label. Next, show.
This is the outgoing label. Okay.
Because the label local and outgoing is same,
it's the same.
It may confuse you. To avoid this confusion, what you can do is go to global mode. Say no MPLS IP. Wait. Okay, put it back, MPLS IP. What will happen is it will regenerate some labels, but the labels that are used already won't be used. Okay, now show IPsef, enter. You see, this is label 16. Show MPLS forwarding table. See, this is local label is 20.
Local is 20 now. Yeah.
It is having only the outgoing label, which is towards the gateway. What is the gateway? See the next stop, 10.4504.
Yeah.
It is not going
towards router 4.
It's not going towards 6 here. You see? Because the CEF table says next stop is 10.45.0.4 gig 00.
Yeah.
Now show MPLS LDP binding. Show MPLS LDP binding for 3.3.3.3. No.
Oh, sorry.
Go with precisely 3333. 3.3.3.3/32. Okay, slash won't come, simply 32. Remove that slash. Space 32.
Space 32?
Yeah. You see? It says the local label is 20, the label given by router 6 is 16, label given by router 4 is also 16. That doesn't matter. Okay, so this is what the question you had in the beginning. Hope you got the question fixed. Yep. So we have done.
What does this mean?
Revision number 2.
Revision.
Yeah, because you refreshed, right?
Okay.
You refreshed and you got new label generated. Now, you see between R3 and R6 we have IGP protocol. We have MPLS enabled. Now what we are going to do in the next class is we are going to bring the VPN up between R3 and R6 with the help of BGP. After which we will have VRFs for this to customer and route distinguisher and route targets, and then allocating the interfaces of the customer to the VRF, getting the routes from the customer, advertising through the VPN tunnel, learning it on the remote side, and so on. All right.
Okay.
So please save these routers before you close. Otherwise, tomorrow you need to do this again. Save this every router. Yeah, you were about to say something.
I was going to say tomorrow